So whose genome is it that we have the sequence of? When we talk about human chromosome 5, the reference sequence, the thing that's publicly available to all the world online as this is the human genome sequence. I asked you this a few classes ago in one of the exit exercises. Whose genome do you think was sequenced? There were a lot of responses from you, which is not surprising. It turns out an anonymous blood donor from Buffalo, New York, where it's cold in the winter and maybe they were bored and were donating blood, provided most of the DNA sequence that we call the human genome sequence, the thing that's in the database as the human genome sequence. What do you think? Fair? Not fair? What do you want to know about this person?
That kind of makes the question then, when you have a reference, like how do you know that is the standard?
Exactly. How do you know that this is the standard? If most of the DNA sequence came from one of the 3 billion of us, is it really the standard? We call it the reference genome sequence. Should it be the reference? What ethnicity was this person? What sex was this person? We can figure out what sex they were because we can find out if there's an X chromosome and or a Y chromosome in the sequence. Right? There's a lot of information we don't know.
Is this person, do we know their health issues, or does it have any mutations or things like that?
So certainly this individual has genetic differences between them and every one of us. Every one of us is genetically unique. There are some differences between every single individual human on the planet. No two of us are genetically identical. So how can we use this sequence as a sequence that can help us learn about humans? So the human genome sequence, the one we're talking about now, was published over a decade ago. And it's been a really great resource. In the last decade, most recently, what a lot of scientists have been working on is sequencing additional people. Right? We started with, let's get a genome sequence to start, which took millions of dollars and many years. Now we're in the phase of figuring out how this one reference sequence is different from other people, other cultures, right? Other peoples, different sexes, people with different health issues. We don't know anything about the anonymous donor. Literally. Totally anonymous sample. Since then, there have been a few exceptions where people who are famous, maybe, have paid to have their genome sequenced and they put that information on the internet so we know whose sequence it was. But most of the time, the sequences are anonymous. Why? So I also asked, if you had your genome sequence, would you make it freely available or would you want it to be kept a secret? What do you think? Opinions about whether or not you'd release your genetic information to the world or not?
We have information on potential diseases you carry or whatever.
So is that good or bad?
Well, personally, I would think it'd be a good thing because somebody, like maybe a doctor who would recognize it as a scientist could help you out or whatever, but at the same time, maybe you just don't want that knowledge public.
That's basically what it boils down to. Other comments, thoughts, opinions about this issue? Do you release your DNA information to the world?
I mean, I think that you can sequence your DNA and then have it available for scientific knowledge, in a database where people that are licensed, medical professionals, are going to use that for.
Yeah.
Or biologists.
Well, you've seen the database. You're not licensed, but you've accessed it. So
yeah, I know.
Everybody's got your sequence if it's in GenBank. Right. So you're probably an organ donor too, right?
Yeah.
Me too. Yeah. So there's some of us who say, yeah, have the information. It helps society potentially. But then there are others of us that don't want to have our health record potentially in the public domain. Especially, it turns out, one of the big issues is the potential impact on healthcare, insurance specifically. If an insurance company can get your genome sequence and they see that you have predisposition for breast cancer, are they going to cover you? I don't know. I would hope they would, but so that's one of the big issues that always comes up when we start talking about genetic information and privacy. Is there some negative uses? You could think of maybe some sci-fi movies where if somebody got your DNA sequence, they could like figure out what your fingerprint was and then place your fingerprint at a crime scene and frame you for a crime. That's not possible, but sci-fi movie. You can imagine, right? Okay. So it turns out that after the original DNA sequence, even before the original reference sequence came out, geneticists had already figured out that you and I differ. If we look at 1,000 base pairs of our sequence, you and I differ about 1 nucleotide in every 1,000. So any two of us are about 0.1% genetically different, 99.9% identical. And that's, again, what I've said in the last decade or so scientists have been doing, is sequencing more people and trying to understand. When you look around, of course, there's a lot of diversity in this room. Skin color, hair color, sex, gender, different proficiencies, different body types. How is it that 0.1% of our genomes, 1 in 1,000 nucleotides, cause all these differences that you see? That's the question that geneticists are working on most recently. If we're 99.9% identical, how are we also different?